The next unit is all about concepts of 8086 microprocessor. Intel introduced its first 16-bit microprocessor in the year 1978. Now we will discuss about the basic properties of 8086 microprocessor. The first property is it consists of 16-bit data bus, and the second property is it consists of 20-bit address bus, and the third property is its memory capacity is of 1 megabyte and its clock frequency ranges from 5 to 10 megahertz. So these are the most or important basic properties of 8086 microprocessor. First property is 16-bit data bus. It means that this 8086 microprocessor is capable of processing data bits up to 16. And next is this address bus is made up of 20 bits and the memory capacity is 1 megabyte. We already discussed that this memory capacity is based on the number of address bits. So now this 1 megabyte is derived using So now this 1 megabyte memory capacity is derived using the calculation that 2 to the power of 20, that is the number of bits present in the address bus, is equal to 1 megabyte. So this is the total memory capacity of 8086 microprocessor. And the last property is its operating clock speed is 5 to 10 megahertz. So these are all the some basic concepts that we know about 8086 microprocessor. Now first discuss about register organization of 8086 microprocessor. So far we have discussed about the concepts of 8085 in the last unit. Due to the drawbacks of 8085, that is only limited number of registers in 8085, it is not so widely used. So this drawback made the inventors to invent the 8086 with more number of registers. So these registers present in 8086 are classified into 4 categories as general data registers, segment registers, pointers and flag registers, and the last one is index registers. So this is the general classification of register organization of 8086 processors. Now let us discuss about general data registers. So the general data registers are further classified into 4 categories as AX register, BX register, CX register and DX register. So each of these registers are capable of holding up to 16-bit data values, since this 8086 microprocessor is a 16-bit processor. So all the registers are capable of holding up to 16-bit data values. This AX register is used as accumulator in 8086 microprocessor. So this accumulator will hold data values of 16 bits, and if the processor wants to process any 8-bit data, then it is also possible using this 8086 microprocessor, such that this AX is further classified into AH and AL. So it is capable of holding 8-bit data, and this lower order register is capable of holding another 8-bit data. So H stands for higher order bits and L stands for lower order bits. So this, if the processor wants to perform any 16-bit operation, this entire AX will be used. And if the processor wants to perform any 8-bit operation, this AL will act as accumulator. Likewise, BX refers to base register. It is also classified into higher order register BH and the lower order register BL. So this base register is used to store the offset value, which will be used for forming physical addresses. The concept of forming physical addresses will be discussed in the forthcoming sessions. And the CX is called as counter register, and this counter register is used for storing looping values in case of any string operations, and it is also classified as CH and CL, that is higher order register and lower order register CL. And the last one, DX, refers to data register, and this is used for storing any implicit operand values, and it's also divided into higher order register DH and lower order register DL. So all these 4 types of registers are called as general data register. So AX is used as accumulator if the 8086 processor performing any 16-bit operation. If it wants to perform any 8-bit operation, then AL alone can be used as accumulator. BX refers to base register, which stores the offset value in case of physical address formation, and CX is used as counter register in case of any looping values are used in the 8086 programming. And then DX is used as data register, which is used to store the implicit operand values, and each of these general data registers are classified into higher order registers and lower order registers. So this is about general data registers. Next we will look into the next type of registers, segment registers. The segment registers are further classified into 4 types as CS, code segment, DS, data segment, ES, extra segment, and SS, stack segment. So these are the 4 types of segment registers: CS, DS, ES and SS. CS refers to code segment. From the name itself, we can infer that in this segment, the executable program or actual application program will be stored here. Whereas in data segment, all the data or the operand values required by this executable program will be stored in the data segment. If there is not enough space in this data segment, then all the additional data will be stored in the extra segment. And finally, all the stack data will be stored in the stack segment. So these stack data will be used only when the processor involves the concepts of interrupts. And one thing we have to recollect here is 8086 processor is popular for its concept of segmented memory. That is, we know that the total memory capacity is 1 megabyte. So this 1 megabyte of memory is divided into 16 logical segments, and each segment consists of 64 kilobytes of memory. So hence this 8086 is popular for this concept, segmented memory. And next we will discuss about pointer register, pointer registers are classified into three categories as IP, BP and SP. IP refers to instruction pointer, BP refers to base pointer and SP refers to stack pointer. This instruction pointer contains the offset within the code segment. Base pointer contains the offset address within the data and extra segment. And the stack pointer contains the offset address within the stack segment. So these pointers are always used to hold the offset value within the corresponding segment. So IP means it contains the offset within the code segment, BP means it contains the offset within the data and the extra segment, and SP, stack pointer, contains the offset within the stack segment. Next we will discuss about index registers. The two types of index registers are SI and DI. These two registers, SI, that is source index register, and DI refers to destination index register. So from the name itself, we can infer that source index registers means this register contains the offset of the source data, and this DI refers to, this DI register contains the offset of the destination data. These two registers are widely used in string manipulation, or specifically used in string manipulations, this SI and DI. Finally, we can discuss about flag registers. In 8086, the flags are classified into two categories as status flags and control flags. So these status flag reflects the status of the 8086 processor after any ALU operation, and these control flags are used to reflect the status of the 8086 after any CPU operation. The status flags are further classified into 6 types as carry flag, auxiliary carry flag, parity flag, sign flag, zero flag, overflow flag. So these the 6 types of status flags. The first 5 categories we have already discussed in 8086 processor. So carry flag means whenever there is an extra bit, that is carry flag. First one is carry flag. So carry flag refers to, or the carry flag will be set whenever there is an extra 17th bit. Extra 17th bit in the accumulator after any ALU operation. And this accumulator and this auxiliary carry, AC refers to auxiliary carry flag, and this flag will be set whenever there is a carry from D 7th bit to D 8th bit. And this parity flag will be set when there is even number of ones in the result. And this sign flag will be set based on the D 15th bit position. If the D 15th bit is equal to 0, then S is equal to 0. If D 15th bit is equal to 1, then S is equal to 1. Then 0 flag, if the result of the entire operation is 0, then 0 flag will be set to 1, else it will be set to 0. Then overflow flag. This overflow flag is similar to carry flag, that whenever the processor is performing any 8-bit operation, then if there is any extra 9th bit, then this overflow flag will be set to 1. Or else if the processor is performing any 16-bit operation and if there is any extra 17th bit, then this overflow flag will be set to 1. Otherwise this flag will be reset. So this is about status flag. Next comes the control flags. The control flags are classified into 3 categories as interrupt flag, trap flag, and the last one is direction flag. So this interrupt flag IF will be set So before looking into the concept of interrupt flag, we know that the interrupt can be classified into 2 categories as maskable interrupt and non-maskable interrupt. Maskable interrupt means whenever your processor receives this maskable interrupt, based on the situation, it can be based on the situation, it can be accepted or it can be ignored. But whenever a processor receives any non-maskable interrupt request, then the processor should attend that interrupt. So, taking this concept, this flag IF will be, taking these concept into account, if this IF flag is set to 1, then all the maskable interrupts should be attended. That is, they should not be rejected and they should be attended by the processor. So this is the concept of trap flag. This is the concept of interrupt flag. Next is about trap flag. When this trap flag value TF is equal to 1, then the processor enters into single step execution mode. That is, the processor will execute one instruction at a time and check for the status of the interrupt pins. This is called single step execution mode. And the last one is called as direction flag. When this direction flag TF is equal to 0, then the string is processed from lowest address to highest address. It is called as auto incrementing mode. and when this value of df is equal to 1, the string will be processed from highest address to lowest address, that is called as auto decrementing mode. So these are all the three types of control flags. So far we have discussed about register organization of 8086 microprocessor. So the four types of registers in 8086 microprocessor are general data registers, segment registers, index registers, pointer and flag registers. So these are all the four types of registers available in 8086 microprocessor.